Hey, good day students. One more time we meet up for another lesson, short lesson. This is rather a very short lesson. Okay, this lesson, my intention is to give the solution or discussion for the last question. Is actually a paper 3 question. I think and this question I posed to you the other day, and I also give you some exercise, and also I post the answers. So I didn't receive any response from y'all. So I assume that y'all can get the solutions and also the answer which I gave. You can match your answers, and I hope y'all got it correct. Unless you have asked the questions, then I would have be discussing now. Anyway, it's still not late. We can still, some of you may not have tried yet, so please try those questions. And you have any doubt about the answer, please post it in the Telegram or in your WhatsApp, so that I can discuss in the next class during the next lesson. Okay, this lesson is a rather short lesson. Okay, and also we are not very sure yet your paper format for your Form 5 SPM. It is of course too early to discuss. Basically, I feel that probably your paper format might change, so we are not very sure yet. But still, it is not no harm in discussing this paper 3 type question. Okay, this paper 3 type question is actually a practical question, okay, which is asked a written practical question. That means it's actually to do with scientific investigation. An investigation on practical part, but we write it the format of the investigation. So it is usually a paper 3 question. It comes about 12 marks in section B. So what I feel is maybe I should discuss this question. This is one of the type of question. Maybe this is the first type of question. You are doing it for the syllabus, for the entire teaching that you have meet up for the past few months during the class. I didn't discuss this type of question, so I take this opportunity to discuss and give you all the answers, so that in future, if there's any such question, maybe you can think of approach how to answer the questions. Okay, for this today, if you look at the diagram, okay, maybe I can read up. You see, so diagram shows Jason taking a shower on a very cold morning. After the water heater is switched on for a while, he still feels cold. Okay, it turned out he didn't get hot immediately, he still feels cold. Okay, then diagram 4.2 shows that Jason no longer feels cold after the temperature control knob of the heater is turned on. Okay. Question 6. Based on the observation on the diagram, using your own knowledge of the effect of current of heating, effect of current on heating. Okay, so here they say the effect of current on heating. I would put this format slightly different. Maybe we can say effect of heating, the time of heating, for him to get the top water to become hot. So let us see how the mode of relationship with the time of heating and also the amount of heat. Actually, this type of questions, there can be a few answers. Alright, it depends how you approach the question, but it must make sense. Okay. Alright. For this question, first they ask to make an inference based on the diagram. So for me, so first when you turn on. When you turn on the heater, you didn't get it hot. So after some time, you feel it's no longer feel. You feel first you feel cold, and after some time, you feel warm. Then after that, you feel normal. That means the heating there shows that Jason no longer feel cold after the temperature knob is turned on. That means the temperature is going up, and he reached thermal equilibrium with his body. So you feel the water is warm as his body. Alright, so that's what they are trying to tell you here. So they want you to understand that the longer the time you take it to heat it up, alright, so the water temperature goes up, and it reaches thermal equilibrium. So basically that means amount of heat is going up with time. Right? So that's one of the approach. Actually there's another approach we talk about the current, but I like to use this approach. It's a very direct approach, that is longer the heat, the temperature goes up higher. Okay, that's what I intend to discuss in this part. Actually I can discuss also on the current part, but that one I don't want to discuss because I haven't learned about electricity. So here the idea is you turn on, the heat is being released by the heater, so the temperature goes up, and then the water become hot and you feel warm. Alright, the temperature goes up, so first you feel cold, then after that you feel normal. So the inference that we can propose based on what I explained just now is, inference is basically we try to infer the situation with the variables that we can observe. Right. Over here I can say that temperature rise influenced by the amount of heat supplied. That means more the heat that you supply, when you raise the current, alright, higher the temperature it goes. Okay, that's what that means. You also can say that after some time the temperature is going up as the heat is being absorbed by the water. Alright, so here you can take note. So always when you make an inference, you always relate two variables. Temperature, amount of heat. So here the temperature, of course, you can measure. The amount of heat is actually correspond to the time. So you can say greater the amount of heat supplied, higher the temperature. How you get the greater the amount of heat supplied? The longer they heat up the water. So from the initial part until you feel the water warm. Okay, so that's hypothesis. So the aim, they ask for the next is aim is to investigate. Okay, again you can see heat supply, temperature. So here we write generally, here more specifically, greater, higher. So always hypothesis, we try to relate the two variables. It's either directly proportional or inversely proportional, but we can't say directly or inversely proportional because we are not looking at the graph part. So we can just relate qualitatively how both the variables correspond. One increase, the other increase, or one increase, the other decrease. These are the two ways two variables can correspond. Okay, so here, so once you got the thing, so temperature and heat you already see, then hypothesis you are making up here, then the next is to investigate, right, relationship between heat supply and the temperature. Right? So you can see everywhere these two variables are appearing. The way it is related is different. Here, first with the inference mode, second is hypothesis, how they correspond, and the third is how you investigate both the variables. Okay, so the manipulated variable here, time or the amount of heat that's supplied, right? Because when you turn on, after some time only the temperature is rising. So time is going up as heat is getting increased. So the responding variable will be the temperature. Constant here, the amount of water that you are using or the rate of heat you supply, alright? How much heat you turn on. Actually the rate of heat supply you can also control by the current, but that part I am not going to. We are just putting it, heat supplied is constant, but it's corresponding to that time. Alright, so rate of heat supply. Procedure. After that they ask for apparatus. We looked at the question, they ask for apparatus. So apparatus I didn't list down. I want you to look at the diagram and then list down. What are the apparatus here? Battery. This is called rheostat and to control the current. This is switch. Ammeter, voltmeter. Okay, all this you can take down. Beaker, water, heater here, and this is the heater, right? This is the heater. Then we have obviously thermometer, right? Thermometer, stirrer, stopwatch, and of course you can say tripod stand, tripod stand, tripod stand. Okay, so these are the apparatus you can list down. Okay, usually you label the diagram. Here I partly only label, I want you to label full, alright? Then whatever you label here, you write down. Usually we don't draw stopwatch, but here I draw. Okay, another way of testing to check whether we have never missed out any apparatus or not, you go for the 5 base quantities that we learned. Okay, first mass. Do we need to measure the mass of water? Here the mass of water is constant. Alright, so we don't need to measure. Alright? Then number 2, what do you measure? Time. Do you need to measure time? Yes. So you have to write stopwatch. Third, you have to write what? Mass, temperature, time, temperature. Do you measure temperature? Yes. So you have to write thermometer. Then length. Do you measure length? Here is not relevant, so we no need to write ruler. Then current. Current, yes. Ammeter is to measure current. Alright? Okay, that's for the heat supply. Alright, so in this question we are not making the current is constant. We are only corresponding to the time. Okay. So the procedure is, usually we write, generally for all the experiment, you write apparatus is set up as shown in the diagram. Alright, so that explains already how you setting up the apparatus. So you must draw the diagram. Okay. Number 2, record initial temperature data 1. That means before you turn on the heater, you record the initial temperature from the thermometer. Alright, before you turn on, you record the initial temperature. Okay, then you turn on the switch. Then adjust the rheostat until the ammeter is okay. So this is to increase the current so that the heater works. So this is going to also fix. And then stopwatch 2 has to turn on simultaneously. So the minute you turn on the switch, you have to start your stopwatch because your heating process starts. Alright? Okay, then number 4, what do you do? And step 4 I didn't write here yet. You can write, okay, what is step 4? You're increasing the time, right? So you have to take a fixed time interval. So you can write step 4. Okay, step 4 you can say at time 2 minutes, okay, 4 minutes, 6 minutes, 8 minutes and 10 minutes. Temperature corresponding temperature is recorded. Okay, so simple as that. That means for every 2 minutes time interval, we record the temperature. Alright. So bracketing, right? So during this process of heating, stir, water is stirred continuously. That means you want to get the temperature even, so you continuously stir for air before you take the temperature so that the heat distribution is even and your temperature is quite accurate. Okay. Alright, the next part of the question they ask how you record your, okay, if you follow the question, part 4 they ask list of apparatus arrangement, okay, procedure done already, the way you tabulate your data. So the way you tabulate your data, simple. Usually when you tabulate your data, put the numbering. Okay, here you are varying the time, right? So time in minutes. Okay. So what's your time here? 0. Alright. Then 2 minutes, 4 minutes, 6 minutes, 8 minutes, 10 minutes. Okay, 2, 3, 4, 5, 6. And temperature. Temperature theta degrees Celsius. Okay, so here just now you already said that theta 1. That's your initial temperature. After that you write down and you don't need to write all this because you are going to record. So initial temperature, okay, then after that you see the corresponding temperature for every 2 minutes. So it's quite a direct question now, right? Heating it up and then water is getting hot as the time goes, as as the heat is being supplied. Okay, so that's all. And the last part, that's how you analyze the data. Alright? So the analysis of data usually in your SPM, these were the format. This is the format going to be. So usually the analysis we draw a graph. Right? So the graph, usually this is, don't forget, this is manipulated variable. Usually you must write a manipulated variable because this one you already pre-planned before you start the experiment. That means you want to take the temperature for every 2 minutes interval, you know already. But responding variable, you are getting the result. You just tell you are going to record that, how you are going to measure it, but you don't need to write the value because this depends on the outcome of the result. So analysis of data, it's very simple. You just plot a graph. Usually this is manipulated variable, so time. Time in minute, yeah, temperature in degrees Celsius. So you write temperature versus time graph. So here you don't need to draw the graph, you are just telling the examiner how I am going to analyze the temperature with time. So it's a very, as I said, it's a very simple experiment, okay. Although they are talking about the current part, I am just based on talking, where I am discussing based on, as the time goes, the heat, the water from first it feel cold, it feel hot later. Alright, so that means the temperature is rising as time goes, as the water is getting heated up. So it's a rather direct, very simple experiment. So this is the expected answer for based on what you learn and what I said. Although it's not 100% following the question, because in the question they ask, based on the observation diagram using your knowledge of the effect of current on heating. That means they want you to change the current and see the temperature is going up as the temperature. So here we already fixed the current. That means you are heating it up constantly, and the time taken, say here the gap is from the beginning until you get the water warm. So the temperature rise, but that's the part I'm talking about. It's not like keeping on increasing the current and the water becoming hotter and hotter. This is from normal water until it become hot to a certain temperature. So you feel water heat. So that's the part I want to discuss. So this is the simple direct answer. So I think that's the lesson for today. So it's a rather short lesson, just discussing this answer for this essay question. So I will go on with other lessons in the next coming classes on still on heat. Maybe we learn another one more new concept on latent heat. Yeah, I'll go in detail about it in the next class. So until then, please go through the answers. And again, reminder: if you have any problem with the question that I gave you earlier with the answers, please post back so that I can discuss in the coming classes. Right? So thank you very much. Have a nice day.